Alright, welcome to the second video in the series on consumer arithmetic. No, just kidding. Complex arithmetic. No, this is something that you've always wondered how you would do if you were in year 9. You know, if you were asked to solve x squared equals minus 1, the answer would have been undefined. But now, because we're solving over the complex field, so we're talking about solving over x in the set of complex numbers, then we have available to us the letter I. Now, earlier on in the first video, we identified I squared to be minus 1. So as we can see, the answer is simply I. Actually, no, because you see, if we decided to do I squared, and we did minus I times minus I, like that, we're still going to get I squared because the minuses cancel out. So the rules of plus minus still applies to these simple basic equations in complex numbers. Okay, so the answer is really plus minus I. Now in this second example, we're going to apply the quadratic formula to this particular equation. So it simply comes out to be x equals to minus 2 plus minus square root of 4 minus 16, because it's 4ac, all over 2. Now to simplify that, we're going to have minus 2 plus minus square root of minus 12 all over 2, which is simply minus 2 plus minus square root of 12 times square root of minus 1 all over 2. This is simply using the third rules. And when you simplify that, you're going to get minus 1 plus minus root 3 times minus root minus 1, which is minus 1 plus minus root 3i. Now, of course, as you get more practice, you'll simply be able to go from this to about that step to about that step. Okay, so you could have skipped the step in between once you're familiar with surds, as well as how to actually extract the letter I from these square roots of negative numbers. Now, if we wanted to do the same question, but this time using completing the square and factoring, then it's a little bit more tricky because we're going to have to complete the square first. Now, normally if you move numbers to the side, you should get used to the idea of being able to complete the square without moving too much numbers to the other side. But I want to just show you that extra step of working anyway. So we're going to have x squared plus 2x plus 1, because that's what completes the square, plus 3. Okay? Now, of course, if you move it to the other side, you can square root minus 3 later on, but here we're focusing on factorizing. So we're going to factorize this, x plus 1 all squared plus 3 equals 0. Now to factorize it even further, we're going to have a difference of squares. So the way I'm writing this is going to be x plus 1 all squared minus root 3i all squared. Now, if you have a just quick look very carefully at what I've done here, I'm actually writing 3, positive 3, as if it was a negative square number, because I can, because there's I squared is actually an extra negative. Okay, now doing difference of squares here, we're going to have x plus 1 minus 3i, as well as x plus 1 plus root 3i equals 0. And solving these two brackets gives us the same answer as before. We have minus 1 plus 3i, root 3i, sorry, as well as minus 1 minus root 3i. Okay, now these are the most basic examples of solving anything to do with quadratics using the letter I. But what if they simply gave you a complex number, such as 3 plus 4i, and wanted you to find the two square roots of it? Okay? Or they might even say it in a simpler way and say solve over the complex numbers. So z being a complex number of z squared equals to 3 plus 4i. Now to do this, we must first begin and say let z equals to x plus yi, as in the real and imaginary parts of this complex number. Okay, in a lot of questions later on, even questions regarding locuses, this is what you actually have to do to begin the question. Now, z squared, We know it's going to be 3 plus 4i. We square it, but we do it very carefully with x plus yi. Now that's x squared minus y squared because I squared contributes a negative sign, and 2xyi, which is the imaginary part. 2xy is the imaginary part of the left-hand side. Now, this is a really important skill. Okay, the skill is to identify and match the real and imaginary parts of both sides. Because, I mean, it's common sense to realize that if you have complex numbers on one side and complex numbers on the other, then for them to be equal, the real parts must be equal, and that's what we're talking about here. X squared minus y squared equals 3, and the imaginary parts also must be equal, which is 2xy equals to 4. So these are the two simultaneous equations we'd like to work on. Now, you might not be able to see what I've just done here, and where on earth did x squared plus y squared come from? I mean, we only had x squared minus y squared. Okay, so the reason this appeared is because this is a particular algebraic technique. If you're ever interested to compare between x squared minus y squared versus x squared plus y squared, it helps to know that x squared minus y squared all squared is x4 minus 2x squared y squared plus y4. Okay, so what actually happens is if you added both sides by 4x squared y squared like this, then your next line is going to be x squared minus y squared all squared plus 4x squared y squared, and this is equals to x4 plus 2x squared y squared plus y4. Now the right hand side simply is x squared plus y squared all squared, and the left hand side is x squared minus y squared all squared plus, I'm just copying that down. Now in relation to these two simultaneous equations we had before, that was simply equation number 1 all squared plus equation number 2 all squared, and that gives us the square of x squared plus y squared. Okay? So in order to sort of square everything, we end up getting a positive number here. Now you might think, wait a minute, how can we guarantee that this is going to be a square number that's actually positive? Well, it happens to be because x and y are real numbers, and we're squaring real numbers and adding them together. So we will always be rest assured that we will get x squared plus y squared equals to a positive number. Might not be a whole number. Okay, now given equation number 3, now that we've worked it out, we'll realize that, hey, elimination method works out very nicely for finding the value of x. We found x is plus minus 2. This is a very important part because when you get two values of x, you need to find two values of y to correspond to it. I like to sort of do them separately because you don't want to mix the correct coordinates up. So when x is positive 2, you substitute this back into equation number 2. This is very important because there will be situations where equation number 2 is 2xy equals to a negative number. When it was negative, if x is positive, y is negative. In this case, because it's positive, x and y have the same sign. So when x is negative 2, y is negative 1. Now, these are actually your complex numbers because you've just found the real and imaginary parts of z. So z equals to 2 plus I or minus 2 minus I. So what you've got to look out for is the fact that 2xy could be sometimes negative. Okay? And when they're negative, it means that x and y have opposite signs. And your answer for z should reflect this. So the cleanest way to do this is to have each individual value of x and solve it for y separately, and then collate them into single complex numbers. Okay, now try the questions at the end of this video.